Namaskar. Welcome to Prakash on Basics. I am Prakash Zog. We started our discussion about lasers. Today, I am going to tell you how actually laser light is produced. This could get a little technical, uh, but it's very interesting. Uh, to begin with, I am going to talk of an analogy. Try to grasp all the ideas that I am mentioning in this analogy, and then later on, as we look into the actual working, just correlate information. I'll help you with that too. Let's think of a situation where there's a big tree with a number of branches, and there are a lot of monkeys sitting on the ground below. On this tree, horizontally, somewhere in the middle, is a very thick, big plank that has been kept fixed. Now, let us say there is a big roar of a lion that takes place somewhere very close by. The result is obvious, all the monkeys will try to go up. When they go up, if the branches are not straight, the only location that they can sit on is on the plank. And gradually the plank will start getting overcrowded. The number of monkeys that are down will be far less than the number of monkeys on the plank. And this typically is a situation that is known as population inversion. Now, suppose the lion is not around after the roar, he doesn't come. So it is quite likely that one of the monkeys will jump down and start moving around. Any monkey very close to it, to this other first monkey, will simultaneously jump down. And when these two begin to run, gradually all the others will simultaneously jump down. This is exactly what happens when we talk of lasers. Keep this story in mind. And now let us try and begin with what lasers are. Let me remind you that the first laser was a ruby laser, uh, 1960, um, and it is typically referred to as a solid state laser because all the parts are solid in nature. We need to understand the structure and how it is built up also. So I have a circuit for it. It is just for you to get an idea as to what things are like. This is the actual circuit that is used to understand how lasers work. The lower two dots represent the high voltage that is being applied. On top is a pair of parallel lines, which remember I had told you long back that they are a representation for capacitors, something that can store charge and leave it out whenever required. And then as it goes around, there is a coil like a tube light that is wound, and this is filled with xenon gas, and it has a little low pressure inside. So the effect is obvious. This acts like a tube light with a xenon gas. And so when the voltage is applied to it, this will begin to glow. Please realize that the amount of voltage required to cause a flash in this xenon lamp is pretty high. So the capacitor in between here will start getting charged, and when the voltage reaches sufficiently high, in a fraction of a millisecond, roughly around 10,000 watts of power will be given to the flash lamp, and a flash of light will come out. The xenon lamp will have discharged. So again, after some seconds, another flash will come and another flash will come, and this will continue. Now, Look what is there in between. There is a rod that is fitted with two parts M1 and M2 written at the two ends. This is a ruby rod. It could be about, they started off with somewhere around 2 to 3 centimeters and about half a centimeter in diameter. Later on, very big versions up to about 30 centimeters were all also produced. This ruby rod is an artificially prepared ruby. What is a ruby? Let's come to that also. Ruby is a substance which is actually aluminium oxide, and to it about 0.5%, that means 1/28th of a part of chromium oxide is added, and it is because of it that the ruby begins to glow in a typical color, something like this Ganeshji here. That ruby rod has the tube light that is wound around it. Please remember, it is not the aluminium oxide that is important, but it is the chromium ions that are there inside of valency 3, which are the ones that are really going to help us produce the necessary lasing action and the laser itself. Now what happens? The chromium ions are at a lower level, which is known as the ground state. That's the lower level. When this flash of light starts going around, all the photons, electrons in it are excited. They go to a higher level and they come back. When they come back, they will come out and give out some amount of light. This is a normal phenomenon we talked of long back to understand how light is given out. But this now is a three-level system. We have the lowest point, which is the ground state, an excited level. This I will call as E1. This I will call as E3. And the electrons can hardly remain in this up to about 10 nanoseconds or so, something. And then they will come back to ground state and again get excited and so forth. But in between, chromium has provided additional levels for the electrons to land up. So they will go up to level 3 and come down to level 2 and start accumulating there, because there they can stay for a longer time. This is in microseconds. That means 1,000 times probably more than the one on top. Such an intermediate stage is known as a metastable state. Let me go back to the monkey story. The highest level is where the monkeys are dancing around, they can't stay there, so they come back to the stable level that is there, and that is the metastable state in between. Now, the number of electrons that are down, they start accumulating in this metastable state to a very large extent because they are being constantly pumped by the flash, and it gets overcrowded. Once it gets overcrowded, there is a problem. Now what happens is, if a particular light of particular wavelength passes through this ruby rod, then it will trigger an electron from the top to jump down, and this process is known as stimulated emission, because the original photon or the light particle is stimulating one more photon to fall down, and they will be perfectly matched, they will be perfectly synchronized, they will be perfectly in phase. And so where there was one photon, there will be two identical photons. But remember what I told you, that at the two ends there are two mirrors. One mirror is a perfectly reflecting mirror, and the second mirror is a partially reflecting mirror. So what happens is the two photons will go and collide and reflect back again. As they come back, they will trigger two more. As they go this side, they will collide and trigger four more. And in no fraction of a time, because velocity of light is very, very, very high. And so the result is all these photons will get all matched up with each other, and a whole strong beam of light, of perfectly coordinated light, naturally of extremely high intensity, which is the laser light, will come out of the partially transparent mirror in the form of a flash of a laser beam. And what is the amount of power? The amount of power could rise to about 1,000,000 watts. So it's a very powerful beam of light that will come out. There's only one problem. Once the electrons, all these of them have come down, it'll take a little bit of time for the population to get inverted again and start coming out once more. So the beam of laser will not come out continuously. It will come out again, again, again. And this type is known as a pulsed type of a laser. So this is how the whole system works. As long as the flash gun or the xenon flash lamp is constantly giving out light, the chromium ions will go up, come down to the metastable state, overpopulate, and suddenly collapse. And again they will build up, and again the process will continue. And this will result into a pulsed type of a laser beam. Light amplification by stimulated emission of radiation. And that's what laser is. And what is the nature? We are using a ruby rod, which is a solid. The chromium ions, which is chromium oxide, actually is finally again a solid. So this is typically referred to as a solid state laser. The trouble is, this was just the beginning of how lasers started off. It was found that other materials could also be used. And very early, one of the gases that was tried out was a mixture of helium and neon. These two gases were mixed together, and then it was possible to bring about the lasing action in it and produce a beam coming out of it. And since the gas was used, this was typically a gas laser. Then they decided if we can use a solid and a liquid and a gas, we might as well try and use a liquid. So what they did was use the liquid, and to this liquid, the liquids could be acetone or similar chemicals that were used. And what they did was they added certain dyes to it, and they produced what are known as dye lasers. So we have the solid state laser, we have the gas laser, we have the dye laser, and there is obviously something in between that we talked of long back, and that's semiconductors. And so they produced special techniques by which lasing action could be brought about in semiconductors also. And they came up with semiconducting lasers. And these could be made to pass through optical fibers. And so these were also sometimes referred to as fiber optic lasers. So we have now so many different types of lasers. Out of them, the gas laser, which uses carbon dioxide with a little small percentage of hydrogen added to it and so forth. This is typically the CO2 laser, which is among one of the most important type of lasers. So this is how the first laser were designed. And this was the simplest way of trying to understand how a laser functions. Once you have this idea in mind, when we talk of how lasers are used next time, I'm sure you will be able to appreciate the way in which they function and the way in which they help us to achieve so many things. If you've liked whatever I have said, try and read up a little bit more about it. Try and understand it once more. Try and tell your friends about it. Like and subscribe to this channel. And let's meet for science once more after 15 days to understand the variety of applications that we have of lasers. They are far more interesting. Let's come to that next time. Till then, namaskar.